Now in this video, you will learn about what is infrared spectroscopy and the wave number of some common types of bonds present in organic molecules and how to interpret the IR spectrum of different functional groups. Infrared spectroscopy is a technique used by chemists to identify the structures of organic molecules. Unlike the proton NMR and carbon-13 NMR spectroscopy, which focuses on the chemical environments of atoms, IR spectroscopy is based on the characteristics of bonds between atoms. So when exposed to infrared light, an organic molecule absorbs, transmits, or reflects specific frequencies depending on the type of bond it contains. The resulting absorption peaks are highly sensitive indicators of functional groups within the molecule. So in the table below, the wave number of some common types of bonds present in organic molecules is shown. For example, this is the IR spectrum of ethanol. It has an OH bond which absorbs at a higher wave number, and it shows a strong and broad absorption band around 3230 to 3550 per centimeter. And the CO bond shows an absorption band around 1300. So here's another example. This is the IR spectrum of ethanoic acid. The OH bond in carboxylic acids often show a very broad and intense absorption band at lower wave numbers, around 2800 to 3550 per centimeter, and this is because they form hydrogen bonds. The CO bond shows absorption around 1300, and the C double bond O shows absorption bands around 1700 per centimeter. In aldehydes and ketones, such as propanone, the carbonyl group, that is the C double bond O, shows an absorption peak around 1710 per centimeter. With the means, the NH bond absorbs at a much higher wavelength, around 3300 to 3500 per centimeter, but the absorption is typically less intense and broad compared to the OH. The CN absorption is around 1250. And lastly, for nitriles, the carbon-nitrogen triple bond shows an absorption band around 2250 per centimeter. And this is very typical of nitriles. So in the workbook, you'll get to practice questions on the IR spectrum and how to interpret the functional groups. So good luck and enjoy.